All right. Thanks, Jimmy. Appreciate it. Just to recap a couple things Jimmy said, I have Eric with me in chat. I would love to make this as interactive as possible. So if you have any questions, feel free to throw those over in chat. Even, raise your hand, speak up in the presentation itself. I would love to divert to what's of interest to you. But in case I miss something, if I'm on a roll, Eric should be there in chat to help out. Thanks, Jimmy, for the intro. And just to recap, I'm here today to tell you a little bit about the open source 51 project, what's new in the .17 release, as well as a sneak peek of our enterprise product called Teams. A little bit about myself. Like Jimmy mentioned, the co-founder and CTO here at Voxel. My background is in computer vision research. So many of the workflows that you'll see in a second were basically built by our company because these are the things that we wished we had when we were building models, both in the research context, also in industry. And also, like Jimmy mentioned, very important disclaimer, and that is that everything that I'm about to show you is completely free and open source. So if you do like what you see, definitely check out the 51 project on GitHub. If you're feeling kind, would always appreciate a star. And with that said, I should probably answer the question first, what is 51? And to do that, let's take a quick trip back memory lane. So 10 years ago, roundabout, computer vision data sets were significantly smaller. At that point, maybe you're working with ImageNet or a small slice of it or some other data set that you've wrangled yourself. And if you were like me, you were probably working with that data set manually. If you want to do a quick spot check on that image data set, you're probably firing up a file explorer, manually poking around with samples. If you've got some model predictions, maybe you're doing some ad hoc scripting, throwing up a little matplotlib plot with some images, a small batch of images and some annotations. But fast forward to now, data sets have gotten significantly bigger, including introducing new modalities like video and so on. And what we're finding is that an increasingly large amount of time is being spent on really the biggest problem to getting an ML project to the finish line. And while you might think it's models and all the interesting problems around what architecture should you use, how can you train the model, et cetera, the dirty truth is that it's really data. Studies show that the typical ML engineer spends over half their time on data quality. With data set sizes getting increasingly large, it's no longer feasible to look at every sample individually. So that's kind of setting the stage for why 51 exists and why our company exists. So what happens if you have poor quality data? Well, it can lead to big problems. Just to throw out some examples that you're probably well aware of, there's issues around model bias. So, the tiny images data set from MIT was shown to have significant ethical or bias issues. Prominent products being released in the wild, like Google Photos, were shown to have issues relating to generalizing to the type of data that these models are seeing in real life, which maybe is different from the data set that it was trained on. And that's a big problem when you're trying to release an ML product that's unbiased and suitable for broad adoption. Of course, the impacts can be more than just soft. They can be physical as well. If you're releasing a self-driving car, it really needs to perform well in these sort of edge cases that are difficult to capture in computer vision. And if it doesn't, well, that can lead to physical danger, real problems that have to be dealt with. And on the more academic side or quantitative side, this issue of poor quality data, it's pervasive in data sets that we all sort of know and love. As an example, we did a study in partnership with Google Research, the creators of the Open Images data set, and showed that if you take the Open Images dataset and you train a typical state-of-the-art model on that dataset, and then you do an analysis of those predictions that model is making, the surprising finding is that at least 30% of the so-called errors that a model is producing on that dataset, they really aren't due to the model's weaknesses at all. It's really due to issues with the ground truth dataset. The old adage, garbage in, garbage out. If you don't have a high quality training data set, your model is always going to be limited in its performance. And so these sort of data quality issues are exactly why Voxel 51 exists. So just to put one slide behind that, our mission as a company is to bring transparency and clarity to data. And we do that through a focus on data quality for all the reasons I just mentioned, as well as bringing to market data-centric workflows that help anybody interested in ML, whether it's a hobbyist, a graduate student, a professional practitioner in industry. We're trying to bring tools to market that will help teams build high quality data sets and address some of these bias issues data management, wrangling concerns that are wasting a lot of time and holding back ML products today. So we're doing that through our project 51. Like Jimmy mentioned, it's an open source project. You can find it on GitHub. You can install it through Python. Quick overview of the product itself. It's the only open source data-centric ML solution. And what that means is that it's going to help you give you a common language to quickly load in data sets, visualize them like you're seeing on the right, which I'll demo in a second, designed to help you run certain workflows of interest to you, like curating high quality data sets, analyzing the strengths and weaknesses of model predictions, slicing and dicing the data set, doing more interesting workflows such as annotation, sending data for annotation, pulling it back from the annotation vendor, finding and addressing labeling mistakes that may have existed in that data set. When you start throwing model predictions into the mix, using the tool to analyze the model predictions, slicing and dicing visually, programmatically, running workflows to help you find where the model maybe isn't performing well, and then take steps to address those issues through curating better data sets, maybe finding new samples that you should add to your training data set to address those issues. All of that happens sort of in the 51 ecosystem. In general, the philosophy of the tool is to play well with friends. So it's not a tool where we would like you to throw away everything you know about ML and just click buttons in the tool. Rather, it's designed to integrate with the other best-in-class tools in your tool belt already, things like your annotation vendor, the way you train your models, the way you deploy your models, the way you track your experiments. Those things sort of fit in with 51 as that data set visualization and management piece. This slide just kind of summarizes what I was saying there. There's basically data and models in your tool belt, and 51 kind of is the glue that helps you analyze the data sets, find issues, and pull in the model and understand what actions you can take on your data sets to improve performance of that model. Here it is in a sort of block diagram form. The typical workflow with 51 is that you have some data coming into your data lake. You can load it into 51 as a dataset object. That dataset object has pointers to the media, maybe locally if you're using the open source tool. If you're using the enterprise Teams product, that data can be in a cloud bucket, on-prem, wherever you store your data. From 51, you can work with those dataset objects and run these integrations with other parts of your stack, like sending data for annotation, exporting it for training, ultimately deploying. And 51 kind of serves as a center of truth or a center of a mass for those data sets throughout your workflows, helping you run these key workflows and iterate on your data sets and watch as they improve over time. So a little bit more detail on 51 itself and what it's meant for. So the tool supports all types of visual data tasks. So common vision tasks like classification, detection, segmentation, working with polygons and polylines, key points, also 3D data. So it supports point clouds as of .17 release, which I'll demo in a second, as well as annotations on those point clouds. It supports grouping data sets. So if you have, for example, a dump from a self-driving car, you can represent the fact that you have maybe 8 camera views of the same scene together with LiDAR data and sort of create data sets that respect those relationships and let you organize and slice the data in that way. Also supports working with embeddings. You're seeing down here, embeddings are a very powerful sort of unsupervised tool for finding patterns in your data. And through 51, and I'll show this in the demos, you can run all kinds of workflows to help to use embeddings to help you find issues in your data sets and use them to recommend a number of things, whether it's new samples you should add to your data set, finding clusters or patterns of failure in your models. Embeddings can be a great tool for that. As well as geolocation. So if you have location data on your data sets, as you'll see in a second, 51 sort of supports that data locally in the app, giving you the ability to interactively visualize and query against that location data as well. I mentioned that it's a Python library on the open source side, and it is, but it's also a very powerful one at that. So in the documentation that you can find at 51.ai, you'll see all the different workflows that you can run through the API on your data sets. Things like obviously automatically loading in data, whether it's data in common formats, data in custom formats. Once the data is in 51, it provides a powerful query language to help you programmatically slice the data. As an example, let me pull predictions with certain box areas, or let me pull the same data in pixels rather than relative coordinates. Query language is quite flexible there, giving you the ability to pull out the particular slice of interest to you and not only visualize it in the app, but then also work with it programmatically to take action on that data. Like I mentioned, integrations are important to FiftyOne. That happens in a number of ways. For example, in the docs, you'll find how we integrate with annotation tools like CVAT. You'll see how the tool integrates with model training, whether it's TensorFlow, PyTorch, higher level things like PyTorch Lightning. Those integrations are in the docs, as well as experiment tracking tools, showing what it looks like to create an experiment and then use FiftyOne to visualize the predictions that these runs have and help reason about whether a particular model with a given aggregate performance might be preferable to another one based on specific outputs that it's generating. Another interesting component of the tool is called the brain. In the brain, you'll find a bunch of interesting data-centric workflows designed to go beyond just the straight visualization and query capabilities of the tool, but really go into the next level where you're trying to identify specific insights into the data sets. So in those, you'll see things like automatically finding potential mistakes that your model's making, recommending new samples, maybe from your unlabeled data lake. I'll actually show that later, that you can maybe add to your data set to address those issues that you're finding with the tool. And then this is where the embedding workflows come in. With the brain, you can automatically compute embeddings. You can provide your own custom embeddings. You can visualize low-dimensional representations of the embeddings and interact with them to sort of pull out and observe patterns in your data. All of that's in the section of the tool called the brain, which I'll demo in a bit. Quick word about the latest release of FiftyOne. So the latest release is 0.17. In that release were a number of new goodies. And by the way, quick shout out to our community who motivated a lot of these features that was added. So by all means, if you see something that's missing from FiftyOne, we would love to hear from you in our Slack community. Reach out to us, tell us what you're working on, tell us what you'd like to see. A number of people have contributed to the project as well, which is of course amazing. We'd love to support that. If it seems outside of your expertise, we would still love to hear because we'll probably implement it soon. So as an example, in the 17 release is when we first released support for 3D and multi-view datasets. I'll show this in a second, but just a reminder, that's where you can work with point cloud data in the tool, visualize it, query it, tag samples, and so on, as well as the multi-view concept where you can have a group of data and sort of interact with it in a HUD like you're seeing there. Already mentioned the geolocation in .17 release is the first time that you have this map tab to work with it through the app. And then beyond that, we also added support for custom plugins in the tool. So like I mentioned, it's important to us that the FiftyOne project integrate well with other tools and also other workflows that you might be interested in running. And so we're doing that in this case by adding support for plugging certain areas of the app. So as an example, you can have a map tab when your data has geolocation data, but you can also add your own custom tab, which is available, and you can hook up to, check out the docs for more details, but you can hook up to your data to pull in different slices of analysis, generate your own plots, really anything you want. It's yours to customize. And there's also a number of other areas of the app, such as the visualizer, which is also pluggable. So check that out in the docs. And just a reminder, you can get links to all this in the slide share after the presentation. Check Slack as well. There's some relevant things in there. I see Eric posted the release notes. From there, you can find more information about all of these features. So with that said, let's go to a quick live demo of the open source tool. Quick pointer to the docs. This is 51.ai. You can find more documentation about the tool. I'll try to call out interesting things as I'm demoing them from the docs. But with that said, here's a Python terminal. I have open source 51 installed. I did that through pip. Let's fire up Python and import the library. So from here, I can see as an example, the data sets that I've created. So in 51, what happens is there's a database. It's a Mongo database that's running behind the scenes. If you'd like to, well, by default, I should say the Mongo database automatically spins up when you import the library. You can also configure it to connect to an existing database. If that's of interest to you, I'll just point out that you can see how to do that under configuration right here. Let's see, database. Custom database connections. You can see how to do that yourself. But in any case, in the database is stored a representation of the data sets you've created. Creating a new empty data set, that's as simple as running this command here. I've got an empty data set and it has no samples. I can, by default, this data set is what's called non-persistent, which means this data set will be automatically deleted when I exit all of my Python terminals on my machine. So you can think of this as a sort of ephemeral data set, like a NumPy array or a TensorFlow data set or something like that. However, I can make the data set persistent and maybe give it a name that's better for me. This data set now will stick around on my machine. It won't go away. And if I wanted to add a sample to it, see, I've got an image on my machine here. I can just show you kind of how this looks. So here's a sample. This sample has simply a file path, and this is representative of how 51 datasets work. In 51, we don't store copies of the media. That's just on disk or in cloud buckets, wherever you store it. When you create a data set, and in particular samples that you add to the data set, you simply provide pointers to the media. And then when you, for example, view this data set in the app, it will pull the data from the file path that you provided. So just to demonstrate the concept, I added that sample to this data set. It now has one sample in it, and it's persistent. So this data set will be around until I delete it, which I can do like this. So I've got some interesting data sets that already exist, like I said, so I could load any of these data sets. I'll do that real quick. Maybe I'll load, I will load a data set, CFAR 100. So this data set contains 60,000 samples. It has some more interesting content on it. It has some ground truth, which are classifications. It also has a custom list field just to demonstrate the idea. So 51 data sets are very flexible. You can continue to add as many fields as you'd like. You can use built-in types like classifications, just to point out in the docs where you can see that. That would be under using data sets and under the section labels, where it documents how you can work with specific task types. So this is showing what it would look like to, extend the example I showed and then add a ground truth classification to the data set, and then maybe a prediction as well with the confidence. So you can flexibly define new fields on your data set. As you do, they'll show up in the data set schema. Whenever you use a built-in label type, those will be visualizable in the 51 app. You can also not use label types. You can use what we would call primitive fields, arbitrary JSON data, ints, floats, lists, bools, and so on. Whenever you populate fields of those types on your data sets, you can still visualize them in the app and filter by them, and you'll get a filter widget that depends on the type of data that you provided. So speaking of the app, let me just launch that real quick. So in open source 51, I'm working, locally. And so when I launch the app, I'm getting a local web server here. And from here, I can load any of the data sets I was talking about. So maybe as an example, I can load this data set. I can interact with it, turn off, turn on certain fields, pull up individual samples, navigate through, can zoom in to inspect in more detail. A number of keyboard shortcuts exist to help you navigate more quickly. So what are the core workflows that you do with a data set in this state? Well, one thing you can do is tag things. So as an example, I'll click on this box here, and I can add a tag to that individual label as an example. So I've now tagged that person. If I come back to the data set here, I can recall that tagged object later. I could also untag it. So just providing you some ways to sort of work with data. You can also tag individual samples, demonstrate that. Cool. So giving you some basic utilities to work with your data here. One of the cool things about open source 51 is the interactiveness between the app and code. So to show you what I mean there, I loaded this data set actually through the app, but I have a hold of it through my session object here. So when I type session.dataset, what I'm getting is a handle to the data set that I'm viewing in the app. And I can do things with that data set. So as an example, maybe I would like to load in the app a new view into my data set where I take 10 random samples from the data set. So I can do that through code, and it loads in the app here. I can do the same thing through the app itself. That's what this thing up here is called. It's called the view bar. So I could shuffle my data set and then maybe limit the number of samples I'm looking at. You can do that like you're seeing there. You can also work with filters interactively in the app. So before I was toggling things on and off, I can also do filtering operations directly from here. So as an example, I can pull up the turtles in my data set and see them, interact with them in that mechanism. If I wanted to do that same workflow, and actually, I forgot to get a hold of the data set in code. Now I've got a hold of the quick start data set. So as an example, if I wanted to filter not through the app, but through code, well, I can do that as well. So let me copy paste a little snippet here to give you a sense for that. So what I did here was I created a view, and that view contains only the labels in the ground truth field whose label is person. And then I'm sorting the data set to show the samples that have the most ground truth objects first. So I used the dataset view functionality to do that. You can see that this view has only 94 samples in it, while the full dataset has 200. And if I wanted to see these samples in the app, I can do so. So you see how you can kind of interactively bounce back and forth, and now I'm seeing only the person objects in the data set. So while I'm here, I wanted to quickly show some of the other new features. So one of them is the geolocation I was talking about. So let me load a data set from the zoo.
Hey, Brian, real quick, we do have one request to take a look at a video data set. Do you possibly have one of those loaded up?
Absolutely. Glad you asked. Like I mentioned before, the tool does support video. So let me pull up a video data set. So here it is. This is the data set that has 150 videos, 190,000 boxes in the videos. So when you work with the video data set, you have a similar sort of layout to the image data set, only you can hover over individual tiles in the grid to see the video played back. And then, of course, you can pull up the sample, interact with it through the app, and still do some of the same operations. You can still tag labels and so forth. Yeah, so that is what video data sets look like. Jumping back to the geo that I was showing. So this is a new feature in the .17 release, and that is that when you have a data set that has location data on it, so as an example, you see that there's this field that is called geolocation. So in the docs, geolocation is a type of label you can put on your data set. So you can provide points, lines, polygons. It's internally stored in GeoJSON format in the database, and you would provide it through a syntax similar to this. So in this particular data set, there's some point data associated with every sample. Every sample has a lat-long coordinate. And so because there's a location field on the data set, there's a tab, a new tab called map. And that map tab lets you sort of interact with the data visually. So as an example, this is near Central Park in New York City. So maybe I'll select some samples here. And I'm now seeing below only the samples in that particular location. And I can kind of click through and interact with it that way. Also wanted to mention 3D support real quick. So there's another data set in the 51 dataset zoo that lets you work with that data. Show that real quick. So this particular data set, it's some samples from the Kitty data set. So Kitty is a stereo vision data set. It has left and right images, as well as point cloud data. So from the grid, I can look at the samples from the left camera. I can switch over to samples from the right camera. When I click into a sample, I now get a sort of HUD that lets me navigate between the different information on that sample. So I can maybe switch between left and right. You see in the bottom, it's maximizing that individual sample. I can still interact with it. Then there's the 3D data. So this is LiDAR data stored in PCD format. With the 51 tool, you can sort of zoom and pan. You can do all the normal things like select even across multiple contexts and then tag those labels, do the same kind of workflows that you need to do. So 3D is now available. Now, I want to quickly switch over to demo some of the capabilities from the brain. So for context, in the documentation, there's a section here called the brain, which kind of gives a summary of some of the capabilities in there. Again, just to highlight some of those, there's a lot of things related to embeddings in the brain and leveraging embeddings and some other algorithms. You can run certain workflows. As an example, searching for visually similar images or identifying unique or non-unique samples or individual objects in the data set, finding annotation mistakes, or mining hard samples. Those are some of the workflows that exist. From this documentation here, you can sort of dive into individual sections. You can see some example snippets. There's a tutorial section in the docs, and what I'm about to demo is largely based on this image embeddings tutorial. So if you're interested in what you're seeing, take a look at this tutorial here. You can download it as a Jupyter notebook. That's how I'm going to be running it. And that's a great way. I would recommend working with 51 open source is to work in a Jupyter notebook. When you install 51, as you'll see in a second, you can run all the same code. And then when you launch the app, it'll pop up in the notebook itself as an output cell. And you can save it and export the notebook and share it. In fact, like what we've done here, this tutorial is basically a notebook that was run through and then sort of exported to HTML in this case. But notebooks can be a great way to sort of summarize findings on a data set that mix visual insights with the 51 app with programmatic analyses or even other capabilities like plotting with matplotlib or doing some model analysis and so forth. So on that note, let me pull up a notebook. One second. All right, so I'm just launching a notebook here. And like I mentioned, this notebook is inspired heavily by this image embeddings tutorial. So do check it out yourself. So what I want to show first is how you can use embeddings on a data set to identify potential hard samples. And then also show how you could, for example, use 51 embeddings to automatically mine new samples from your unlabeled data lake and pull them in to address those hard samples. So to do that, first step, I won't run this cell because I've already run it, but we have, we'll work with the MNIST data set. It's available in the 51 dataset zoo. It occurs to me I've mentioned the zoo a few times, so let me just highlight it in the docs real quick. When you are looking to load data into 51, there's a whole page in the docs dedicated to that. Quick plug, if you have data stored in many common formats, you can load it into 51 with just one line of code. I pulled Cocoa as an example. If you've got some Cocoa formatted data, you can load it into a 51 data set like that. If you want to work with a data set that's publicly available, chances are good that you can find it already packaged in our dataset zoo. So just to pull this up, here's a number of data sets that are available in the 51 dataset zoo. In fact, the official Cocoa data set's available. So if you wanted to work with Cocoa, you can run this load zoo dataset command that you saw me run earlier. For many data sets, we've actually gone a bit further and added some capabilities like you're seeing here, where I'm saying, I don't want to load the entire Cocoa data set. I know this would take downloading a lot of images and so on. I want to do a quick peek into 50 random samples from the validation split. When you run this command, 51 sort of knows what to do. It'll download only those 50 images and give you the ability to quickly take a peek at that data. You can do a bit more than that. You can even say, I want 25 samples, but I only want segmentation labels, and I only want images that contain cats or dogs. Those kind of syntaxes are available too. So do check that out. But yeah, back to the demo. I've got the MNIST data set from the zoo. The MNIST data set has train and test splits in it. So this is an example of what it would look like to pull out only the test split, leveraging 51's tags capabilities. All the samples in the test split have a tag called test, so I can pull those out there. And now I want to work with embeddings, and in particular, I want to visualize the data set. So in this case, these are small images. I'll use as embeddings just the unraveled images. So this is number of samples by number of pixels array. You can pass it into the brain method called compute visualization, and that will give you the ability to visualize that data set. So let me show you. Like I mentioned before, I've already run this. So here I've loaded the data set. Here I'm pulling out from those 70,000 samples, just the 10,000 in the test split that have the test tag. I already ran this compute visualization method, and so I have on my data set the results stored under what are called brain results. So when I ran the visualization, I stored under this key MNIST test some results. So I'm just loading those. So let me first launch the app. So like I mentioned, the app is here in the notebook cells, notebooks output cell, and you can interact with it, do all the same things as usual. But in this case, I want to visualize those results that I generated earlier. So what I'm saying here is I took those embeddings. Every sample in the data in the test split of the data set was embedded into 2D space, and I want to visualize those in a scatter plot. And in this case, I have labels. And so I want to visualize the points colored by their ground truth label. So that gives me this plot here. And the neat thing with 51 is you can attach plots like this to your session and make them interactive. And again, this is all open source. Check it out completely for free. So let me, so you see here, there's a cluster of zeros together with some other things. So let me just pull up only the zeros first. I can select this cluster, and in the app, we'll load up only those 966 samples that I selected. So these are all sort of typical looking zeros. These are a little interesting. These are zeros, which are they're still zeros according to ground truth labels, but they are very far away in embedding space. So you see there's some interesting behavior there. Also interesting might be the points that are not zeros, but were very similar to zeros. So maybe we can just pull those up. There's a number of different things in there, but you can see, right, these are 6s and 2s and 8s and so on that are shaped more similarly to zeros. So kind of interesting stuff. Just a quick call out, all of the same interaction capabilities, those still exist. So here I selected 37 samples by interacting with this plot. But if I want to work in code, I can do that. The session.view gives me that current view. So here it's giving me a view that I can do anything with in Python that contains only those 37 samples that I selected. And but let's continue the experiment. So first, let me freeze my session real quick. When I did that, it replaced the app here with an image. So if I were to leave this notebook and come back, I would see exactly what I was looking at. Same thing with this. But now let's consider a more interesting workflow. So I also generated a 2D visualization of the entire data set, which also includes a bunch of other samples from a different split. And for the sake of demonstration, let me do a new visualization of those where I'm visualizing in a slightly different way. I'll just pull it up. It's easier to see. So now I'm looking at a scatter plot of all 70,000 points in the data set. And for the sake of experiment, there's all the same 10,000 samples that we were looking at before. But now I've added in all of the samples from the other split. And for illustration purposes, I'm coloring them as unlabeled. So obviously an interesting finding here is that all of these unlabeled samples, well, they are very well clustered with samples whose labels I do know. So this is interesting, right? If I want to take action on this as an example, here's the cluster of zeros. Maybe I want to show only the unlabeled samples, and well, these are probably zeros, so I can select those. Again, we're pretending those were unlabeled. So now I've selected those 5,976 samples, which are very similar to the ones that are labeled as zero. So I could come in here as an example and give a label to all of these that these are probably zero. So now I can repeat the process, and I basically have done some pre-annotation of samples with sort of estimated labels. And of course, the cool thing about FiftyOne is that you can automate that. You could write code to do the same thing. All of these capabilities are exposed not only through the visual interface, but if you want to do a sort by similarity, where you, for example, find the nearest neighbor of every unlabeled point, well, you can do that as well through the API. Just to give you a more maybe realistic case, let me now load another data set and then not use the full image as an embedding, but a more typical case where I'm working with a deep model. So FiftyOne also has a model zoo. I can load a model there. This is showing how I can generate some embeddings of those samples, and then I can repeat the process and visualize those. So let me just show what that looks like. So here's this new data set. It's got a few different label types. I'm interested in time of day labels. So there's daytime and nighttime, as well as some other ones there. Let me generate a scatter plot of all of those images. So again, the scatter plot represents images. Every point is an image embedded with this MobileNet model that I pulled out of the model zoo. And I colored the points by time of day. So as you might expect, there's some clustering between nighttime samples and daytime samples. That's pretty interesting. There's also some outliers, which are instructive. So let me select these outliers as an example. What are those? Well, these are samples where the dash of the car is present in the image. So kind of an more prominently present, which is an interesting sort of unsupervised finding. Let me pull out these samples here. A little bit of an outlier as well. Those are samples where it's raining. In particular, there's rain on the dash. You can see here that pulling up samples which are raining, which is kind of a cool finding. But another thing of even greater interest would be, inside this cluster of daytime here. If I hide some of these other ones, I see a bunch of points which are labeled as night, but they were in the wrong cluster. And so if I just pull those up to inspect them, my app seems to have broken. 1 second. All right, new plot. Looking at night samples, which are in the wrong cluster. So if I just pull those up real quick, you see exactly what we might have expected. We see samples which are labeled as night, but as suggested by the embeddings, those are actually daytime samples. So these are annotation mistakes. So I could, for example, tag those issues here and then run another workflow where I send those samples for re-annotation, whatever workflow I may have in mind. But again, example of an interesting finding you can get while leveraging the brain of the tool. Together with this interactive visualization in Jupyter Notebook. So with that said, let me hop back over to the slide deck. Again, everything I showed there was open source. And so if you like what you see, definitely check out the GitHub repository. If you're feeling generous, give us a star. We'll be eternally grateful. Any questions that popped up about open source?
So there were a couple of questions in the Q&A that we chatted about there. So one of them being, can you use geolocations of object patches? So yes, there is a way to do that, and I linked a little code repo there, or a little code snippet that you can check out to see how to do that. Another one was, can you do the embedding visualization you were showing, Brian, in the app, similar to the map?
That is an excellent question. So that one is on the roadmap for us to formally support very soon. It's actually already possible through the plugin mechanism that I mentioned earlier. If you wanted to basically add your own custom plugin that would just put that plot in there, you could actually do that. But short answer to the question, 100% plan to soon add those embedding workflows into the app, similar to what we did with geolocation.
Awesome. See, there are a couple more questions. But yeah, I think you can go ahead with the Teams demo for now, and I'll circle back around for any other questions that popped up.
Sounds great. And quick reminder, if you want to talk in more detail about any questions, do join the Slack community. We'd be happy to have a conversation with you over there and get you connected with, the answer to the question. So quick pivot over to FiftyOne Teams. So Teams is our enterprise product. And just to give you a sense of why the difference between FiftyOne and FiftyOne Teams. So open source FiftyOne, like I just demoed, it's fundamentally a Python package that you install locally. It's really optimized to be as powerful as we can possibly make it, but only for individual users. So you won't find in the open source one the ability to sort of spin up like a SaaS web portal or something like that, or share findings with friends or with colleagues. That's what the enterprise product is about. So with FiftyOne Teams, you get a little bit more infrastructure. You'll have a dedicated web portal where you can log in and start working with the app, and I'll show it in a second. In addition, more beyond what you can just do with the open source web server locally. So you can log in directly through the web, can be integrated with your organization's authentication. Supports cloud-backed data sets. So you can have data sets whose media is stored in cloud buckets that you control, or this can be deployed on-premise as well. So some additional sort of capability to collaborate on the same data sets through the tool. There's a few other features there that I'll show in a second around permissioning and versioning of data sets that are relevant when you're working on data sets together. If you want to learn more about this, you can check out this link here, voxel51.com/teams. See more information about it, reach out, and we'd love to do a demo for your team. But onto those new features. So one of the things I mentioned is in that persistent web portal, you can work with your data sets in a more organized way. So you have a new page where you can sort of see all of the data sets that you have, pin data sets, and sort of navigate your data sets through search and filtering capabilities to make it easier to manage them. You can also control access to data sets. So now we're talking about a deployment where you maybe have multiple members of your team all working on the same data sets. So you can, for example, control things like whether a person has edit access or view access or can manage the data set. And you can do that on an individual data set level all through the web portal. Also in scope in Teams is dataset versioning. So if you're collaborating on a data set together, you're trusting 51 Teams as the one source of truth for that data set. Well, data sets are living, breathing things. You need to be able to roll back to older versions, or in general, always be able to pull up exactly the version of a data set that you trained a model on. That's the scope of the versioning feature. Again, something that's available through the web portal for Teams deployments. So let me show you real quick what that looks like. So here is 51 Teams. Like I mentioned, so what I've done actually is logged in already. So I logged into my account on the deployment, and here I can see a list of the data sets. I can, for example, pull up an individual data set, and like was mentioned, I can come over and manage that data set. In particular, I can manage access to that data set. So a couple of features there. One thing you can do is say, you know what, all members of my deployment, I want to grant a specific default access. Maybe I want no access. I want no one to be able to view this data set unless they have been given specific access down here. Or you can say, I would prefer all of the members of my organization to have view access. You can do that as well. And then, like I mentioned, you can grant specific access to an individual. Let's see. I don't think Eric has an account. I could grant access, for example, to Topher, to this data set, and from there could control the specific permissions that were granted. You can also control access to your deployment writ large. So just to give you a quick rundown of the model there, there's different roles that users can have. One is admin. An admin of your team's deployment has access to all data sets always. They can always see what's happening on the platform. The default role would be more of a member role. Members have what I was talking about earlier. They have the ability to access all data sets for which default sharing was enabled, but may not be able to access data sets for which default sharing was not enabled. And then the last type is guest. So a guest user is a different type of user on the system. How do you invite a guest to the deployment? Well, as an admin, you can come in here and you could type in the email address of the person, and you could grant them guest access. And as the name implies, a guest would only be able to see data sets that they've specifically been invited to. So if I were to invite a new guest right now and they log into the portal, they wouldn't see any data sets until I specifically share it with them. So giving you a way to sort of collaborate on data sets and manage access to them. You'll also see from this page, I can pin data sets. So I can, for example, record some data sets specific to me that I'd like quick access to. And you can also sort of find data sets through a number of common filters. For example, if I wanted to see my largest data sets first, I can do that. Or if I have in mind a data set that I gave a specific tag to, I can access it in that way. So yeah, just a few capabilities centered around teams that you get when you do an enterprise deployment. And just to call out everything about that you can do through Python and so forth. This is continued to be supported through Teams. You can still install the 51 Teams client, and you can connect to and work with any data sets using all of the workflows I just demoed, including launching the app locally if you want to, on a Teams deployment. In this case, as long as you have access to those data sets. So I would only be able to work as a Python user with data sets that had been specifically shared with me. Or obviously if I were an admin with any data set. And so basically the way that works is you provide an API, or you generate an API token for yourself that you would then use to connect to using the Python client if you want to connect to the deployment and interact with data sets.
Yeah, so we did have one question related to that regarding how does like the session object versus app connection work in Teams. So yeah, you can take that away.
Yeah, good question. That was one thing I wanted to point out. So when you work with Teams, you can still, that Python session that I had running there, that might as well have been a team session because you can continue to run all of the same Python-based workflows. If you want to do the interactive capabilities that I was showing earlier, you would basically run the same workflow that I was running here. You would just import the library and you would launch the app. When you launch the app locally using a Teams client, you would get a local server that you can interact with in all the normal ways. But again, only pulling in the data sets that you have access to. So the short answer is that for interactive workflows, you would rely on launch app at this time. Future state will be adding support for doing the same thing in this deployment as well, where you can then have sort of a collaborative, interactive experience on data sets.
So we had one question asking that some of this seems a little reminiscent of what like Scale and Labelbox are working on. So can you go a little into detail of how this differs from their offerings?
Yeah, great question. So in general, I would say that 51 and 51 Teams is designed to be extremely flexible and extensible. So all of these workflows that we're talking about here through the Python library, hopefully some of this demo I was showing here conveyed to you that the level of flexibility and customization that you get when you're working with the 51 data model as opposed to one of those other services. Now, when it comes to the team-based deployment, they are serving similar services in terms of giving you a place to organize data sets. So what sets 51 apart really is, number one, that you can expect from our Teams product tighter integrations with other capabilities. For example, the ability to send data directly through the Teams application to whatever annotation vendor you use, or the ability to work with experiment tracking tools in a Jupyter Notebook context, as an example. So 51 sets itself apart in terms of its flexibility. And of course, the open source, right? For us, it's a equally large win if a user comes along, finds the open source tool, and enjoys all of these workflows as an individual. And then, obviously, if you're an enterprise and you need some of these Teams features, we're there for you as well. But yeah, the open source aspect is a differentiator.
Awesome, thank you. So got another one. What is the intended scope of Teams? Do we ever intend to adding, labeling or a model registry to search and metadata on models? What's next for Teams?
That is an excellent question. So the future is obviously bright, and there's a lot of capabilities that can be added. In general, what I would say is that on the roadmap is to make the enterprise user's life as easy as possible as it relates specifically to data, right? So all of the ways in which we can make annotation or QA workflows easier, you can expect additional capabilities built into the tool to support those things. To the extent of giving you a place to store models and data sets, yep, you can expect more capabilities in the Teams product to help you work with models. The one thing I will say is that we do take seriously integrating well with other capabilities. And so there'll never be the claim that you should throw away all of the rest of your stack and only use 51's capabilities. We're really laser focused on data set quality and curation issues. Because that's the sort of unique lacking element in the market.
Awesome. So another question about, you have all of these trained models on the data sets in 51. Can you integrate, this versioning system for your experiments and actually track, how your models are performing and store all of that data? Do you have any integrations like that?
That is an excellent question. And what I can say is you should stay tuned in our Slack community and our blog for some more information about exactly that topic. But long story short, yes, the goal of 51 is to give you, especially with the versioning feature, is to give you a very tight coupling between analyzing a model, whether it's, just as an example, I didn't even talk in this presentation, but 51 has model evaluation capabilities built into it. There's this whole section here as an example, what it would look like to evaluate an object detection model, both visually as well as through traditional metrics, PR curves, and so on. What you can expect is 51 to continue to let you analyze your models in a sort of hands-on specific way that we are, in terms of like letting you view, the fine-grained details of show me the samples with the most false positives across my data set, things that are difficult to do with other tools. But indeed, we want to integrate well with other flows that you might have built in terms of experiment tracking or the way that you train models. And so what we'll be blogging about and releasing as features soon are tighter couplings between what it looks like to version a 51 dataset and hop over to your experiment tracking runs and vice versa to sort of get more hands-on with analyzing models.
Alrighty, and then one final one. Have there been any interesting non-ML use cases of 51 that you've heard of?
Yeah, interesting. So in terms of non-ML use cases, one thing I would point out is that the tool is definitely optimized for non-ML people. So as an example, one of the things you can do with 51 Teams when you can log in directly through the app is run QA workflows. So having non-technical people in there, pulling up individual scenes, tagging issues, sending data for annotation, and so on. These are obviously non-ML users, but still ML use cases. In terms of completely non-ML use cases, I mean, as some of these tags indicate, in the Slack community, we've seen all kinds of really cool data sets from, these are real examples: agriculture, healthcare, retail. So really interesting data sets have been loaded up into 51. And whether or not they have any sort of machine learning based ideas in mind for how to work with it, seeing that data in 51 and being organized and basically being a souped up file explorer is always an interesting experience.
Alrighty, thank you. Yeah, that was the last 51 related question. Just have one more in the chat about employment opportunities at Voxel 51. So let you take it away.
That is a great point. And I will hand this off to Jimmy real quick to wrap us up. But if you liked what you saw, here's some ways to get involved. Again, we'd love it if you check out the GitHub repository, give us a star, join the Slack community. Links are here. The documentation for the tool, that's at 51.ai. I was clicking into that a few times. If you want to see more about teams, check out this link here. And if you'd like to join our team, that would be amazing, because we have a lot of open roles, which I think Jimmy will talk about in a second. But yeah, thank you.